Welcome to this brief introduction to MiniZinc. So MiniZinc is a constraint programming modeling language, and it's designed to solve discrete optimization problems. And this is a very vast area. There's lots and lots of ways of solving discrete optimization papers, lots of research about that. But one of the key things is that problems have a lot of structure in common. And in the constraint programming view of the world, these are captured in what's called global constraints. So here's some examples of global constraints. The regular constraint says this sum sequence is an element of a regular language. Very powerful. Disjunctive constraint says we've got a whole lot of tasks, but only one of them can be running at any one time, so they don't overlap in their runtime. And geost is an overlap in a 2D space, so we've got some objects to pack into a 2D space so that none of them overlap. Now we can use directly in MiniZinc these global constraints to express parts of our problem. So let's have a look at a small example. Here's a cyclic rostering problem. So Anne, Fred, Sue and Bob are all going to do the same roster. They're going to just start 1 week off. So Anne will start with a day shift, followed by a day off, a night shift, another night shift, a day off, and another day shift in the first week. Then she'll move on to the second week. So the next thing she'll do is another day shift, another day shift. Fred, in the first week, will be starting this shift. So all 4 of these people are doing the same cyclic shift, right? And so we'll go through generating this sequence, and notice this sequence will satisfy some constraints, like we can't do more than 3 day shifts in a row, we can't do more than 2 night shifts in a row, and we can't transition straight from a night shift to a day shift. Now, in order to make sure that these constraints work from the transition from the last week to the first week, we have to actually put a copy of the first week at the end. So now we see that from the 4th week to the first week, we also satisfy the constraints about number of shifts in a row, etc. All right, so that allows us to force the cyclic roster. And then we have some other constraints. The constraint of the problem is on each day we need between 1 and 2 people doing a day shift or a night shift. You can see that those constraints are satisfied. So our CP model really consists of 1 regular constraint, which is basically making sure this sequence satisfies all those constraints, and 7 global cardinality constraints, which count in each day how many shifts are done in total by all the people. And that's the entire model, just 8 constraints, making use of this common global substructure. So here's a part of the model. It's actually quite big. We have to build up a big state machine to define this regular constraint. We can see the global cardinality constraints are much simpler to express, just there, one for each day in a loop. Now, one of the key things about MiniZinc is it attaches to many, many different solvers. The idea is that the model we're writing is independent of the solver. Now, this is easy for CP solvers, which may directly handle regular constraints and global cardinality constraints, but non-CP solvers only accept a very limited subset of constraints. So MIP only allows linear equalities and equations, SAT only allows Boolean clauses. And what MiniZinc does is automatically translate the model using these high-level structures into these low-level possibilities that some solvers accept. So, for example, here where we've currently selected the G-code solver to solve our problem, we might want to change that. Let's go and select a different solver. In this case, we're going to pick HIGHS, which is a mixed integer programming solver. We're going to go into configuration editor, let's say, and choose to turn the pre-solve option to on. And we can go away and run our program. So we can basically use the same model with very different solvers, and we can modify those solvers to use different parameters if we need to. So that's one of the powers of MiniZinc, that we can try all these different kinds of solvers. It comes with about 6 built in, but there's many, many more out there. More than 30 solvers, I think, support MiniZinc. So why is this important, solver-independent modeling? Well, if we look at our workforce rostering problem, we showed you a little bit of a CP model with 8 global constraints, right? Very natural way of writing it for a CP perspective. A MIP model wouldn't write that way. They would write a much bigger model and with mostly linear constraints, or things very close to linear. But it turned out we built this, experts in both rostering and modeling, and our CP model ran better with the MIP solver. And our MIP model ran better with the CP solver, which shows you that even experts can find it difficult to know what's the best model for a particular solver or what's the best solver for a particular model. And that means solver-independent modeling is valuable because it allows us to experiment with that really, really straightforwardly. Otherwise, we have to do a lot of work to build a new copy of the model for each solver in a separate way. So MiniZinc brings together all these tools, allows you to easily create MiniZinc models. You can use things like FindMus if you've got an unsatisfiable problem. The most frustrating thing when you're modeling is you say, oh, here's my model, and the solver just says, no, there's no solution. Obviously, that means either the problem you're trying to solve has no solution, which is unlikely, or you've written your model wrongly and there's an error. So FindMus allows you to track those things down quickly. There's a Python package. You can easily embed MiniZinc calls inside Python and use MiniZinc inside a larger application that way. So if you're interested, then come and visit our website, www.minizinc.org. You can try MiniZinc in the browser. You don't even have to download it now. And you can learn much more through our online tutorial and documentation. And there's free Coursera courses which will allow you to learn MiniZinc.